Okay, how do we find the area of a rectangle? Well, we do the length times the width. Wump, 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 wump. And that gives us the rectangle. What is the area of this rectangle as I've just drawn it? 1, 2, 3, 4, 5, 6 by 2. So what is the area? Right? Everybody got it? No problem. Yeah? What is a square? Antonio?
Special rectangle is sides are opposite.
Right, it's a special rectangle. I don't know why I'm writing in red. Red is a pain. A special rectangle. So, since it's a rectangle, it's still length times width. Except they're the same. L equals W. So how else could we write this? If L and W are the same, I can change the variable, can't I? I can call this S for side, right? So the area of a square is LW, but it's also SS. And what's the shortcut to writing SS? S squared. Everybody cool? This should be no problem. Your grade 9 math teacher probably did something exactly like this to explain square roots to you. I hope he or she did, because this is where it comes from. It comes from the fact that the shape, the side, builds the whole shape. Everyone is good? Okay, so if you're provided with the area, how do you determine the length of each side? Well, if you're provided with the area of a square, you know that area equals S squared, right? So if you know the area, the example I'll give you, 16 equals area. You guys all can do algebra. 16 equals S squared. When you get to this point in algebra, is the S isolated right now? No, because he's squared. How do we isolate variables? We do the opposite operation, correct? So, if it's squared, obviously we need to square root both sides. Now you, again, already know this, right? But I'm betting most teachers stopped at calling it a square root. So I'm going to go a little further with that. First of all, this symbol right here, we got to know what it is. It's the radical sign. That's what it means. Okay? And what it means, essentially, is we are looking for factors. Now, we talked about what factors were before. This symbol is asking me, when it's drawn like this, to find the two equal positive factors. Okay, please highlight positive, because of course the square root of 4 we all know to be 2, right? But we always forget that it's also minus 2, isn't it? Because negative 2 times negative 2 is positive 4, yeah? So for our intents and purposes, in the 10th grade, we are only looking for the positive ones, even though every perfect square has 2 roots, a positive and a negative. Everyone cool? Yeah? Okay. We are only looking for the positive one. Now, that's what you did last year. Last year you probably didn't do volume, but we did volume in this class. So we got a rectangular prism. How do I find the volume of this guy? Area of the base times height. Well, the base, I'm going to use the top here because, of course, it's visible. Length, width, and height. So, rectangular prism is LWH. The LW is my base area. And the height is my h. Right? We already know that. What is a cube? Not what if it's a cube. First of all, before we write it down, what is a cube? Antonio, you're on fire today. Mostly because nobody else wants to say anything. All the sides are the same. So, if it's a cube, it's still a rectangular prism. Oops, rectangle prism. But LWH are all the same. So I've got L, oops, I lie. I've got L, W, and H. But since they're all the same, it's the same as saying side, side, side. Yes? So volume equals LWH, but it also equals side, side, side. Side, side, side we write as side cubed. Right? Everybody's okay with that, yeah? This is all grade 9 stuff. So now if we get a volume of a cube equals S cubed. If you have the volume, for example, 27 equals S cubed, now what do you got to do? When it was S squared, it was real easy, right? Square root. So now we need a cube root. You guys are smart kids. What's a cube root? If a square root is 2 factors, what's a cube root? I know someone other than Antonio can actually answer this question. I got all morning. I don't care. 3. Excellent. Why? Because there's 3 of them. It's side, side, side now. So I must need 3 equal factors. So this symbol, please look at how it is different. What is different about it? It's got that little 3 there. So it's asking me to find 3 equal factors. Not factors. That sounds naughty. Wait a minute. Where are we here? There. 3 equal factors. All right. So, the small 3, because that's the only thing that's different, right? The small 3 is called, and please, I'm going to write this in a different color, and I'm going to highlight it. The small 3 is called the index. Okay? It is the number of factors we seek. Okay? Now, listen carefully. Am I going to have room there? No. I'll do it down here. First of all, perfect square, perfect cube. Please highlight the words perfect. A perfect square or a perfect cube is any rational number that has square 2 equal rational factors, and a perfect cube, which I will change color to right, has 3 equal rational factors. Okay? Now, what do I mean by that? Well, what's the square root of 4? 2. 2 and 2, are they equal? Are they rational? Excellent. Okay. So everyone's cool with that, right? But there's perfect squares that don't look perfect. For example, 6.25. What's the square root of that? 2.5. because 2.5 times 2.5 is 6.25, right? Now, this, a lot of people are like, well, that's not a perfect square, but it is, because its factors are still rational, because that's 2.5. The decimal ended, didn't it? Everybody okay? So 6.25 is a perfect square. But normally, when we say perfect square, we mean the ones with no decimals. You picking up what I'm putting down? And cubes, same thing. At the bottom here, you will notice that I have given you a very important piece of advice. We're going to do that in a second on the next page. But in the bottom here, I want you guys to write this following construction. Y root x. Okay? So y, we already know it's the index. And the x is what we call the radicand. And the radicand is the number. That is where we break that down for factors. Okay, and the index, of course, is, once again, the number of factors we seek. Everybody okay with that? All right. Now, on the next page, it says list the first 20 perfect squares, the first 10 perfect cubes. I'm never going to test you on that, but when we go a little further with this lesson, you will see how useful it is to have them memorized. And when I say memorized, again, what do I mean? Memorized. Okay? The way some people know their times tables. How I can say any two numbers up to 12, and by the time I finish the last breath of the second number, you've already told me the answer. That's what I mean. Everybody cool? Again, though, will I test you on it? No, because this isn't memory 10. This is math 10, right? But it will be helpful if you know them. Everybody cool? So if you were in my grade 9 class, I made you do this anyway. But if you weren't, you should. Perfect squares from 0 to 400. So we'll start with 0, of course. 0 is 0. What's 1? 1. 2. 4. Right? 3. 9. 4. 16. 5. 25. 6. 7. And carry on. Everybody good? Like I say, it will be very useful if you have those memorized. And the cubes, don't laugh. It helps me to remember to make a funny face. The funny thing is, psychologists have proven that when you're trying to remember stuff, and you guys all do this, you look up, right? Depending on what you're trying to remember, that affects where your eyes look. Because your eyes are actually looking to the part of your brain where the crap is stored. True story. Which is why when you're lying, you often look not down, you look up and to the left, because that is the imagination part of your brain. True story. So if you want to learn how to fake out your parents, and your parents have done any amount of psychology, don't look up and left. No, your parents know you're lying because they believe every word out of your mouth is a lie. That's the best way to parent. What are you doing right now? Eating breakfast. No, you're not. You're lying. That way you're always covered. Mr. Peters. Yeah. Anyway, Sam, that's how I go. I choose to believe that everything out of my kid's mouth is a lie. Unless proven otherwise. Guilty until proven innocent in our house. Okay, everybody good? What? Well, it's just cubes. 2 times 2 times 2 is 8. Oh, you're not done copying it. All right. Well, so I can slide down to there, can I not? All right. Now, again, your grade 9 teacher should have done this with you. So, again, I'm only going to take a moment to do it. To estimate the following. Well, there's 2 kinds of ways to estimate this, right? One, you can punch it into your calculator. Because it's not going to give you a nice answer, is it? It's going to give you an irrational number, which is not the exact answer. So if it's not exact, it's an estimate, right? So that's one thing you can do. That's not really useful to me as a math teacher, to know that you can punch stuff into your calculator. That's pointless, because everything on the last 2 tests I've given you is punchable into a calculator. And if all that you needed to do was able to punch things into a calculator, you all should have gotten 100% on your last 2 tests, right? If it was only about a calculator, we all should get 100%, right? But it's obviously not. So I want to make sure that we take a moment here, just a moment, to do these first 3. And I've got them horizontally to show you with some space for work. Once you see how to do it, you won't need the space down here. So, again, all of you did this in the 9th grade, but we're going to have a look at it anyway. Is 72 a perfect square? No, right? What's it between? 8 and 9. So 64 has a root of 8. 81 has a root of 9. Yeah? Right? How far is it between 64 and 81? 17 steps, yeah? Right? And 72 is 8 steps past here, right? So, if 72 is right there, then the root of 72, right, is logically 8 and 8 steps out of 17, isn't it? And that's pretty darn close. I'm using the squiggly equal sign because it's close to 8.5, isn't it? So our estimate there would be 8.5. Everybody with me? We go to our calculator just to double check. Square root, 72, 8.48, 8.5. Cool? Again, the reason I'm getting you to do this is because your calculator punch-in is great, all things perfect, but if you can estimate beforehand, you have an idea of where you're going. And when you get a crazy wrong answer, like a hypotenuse that's shorter than a leg, You can say, oh, okay, I got this. Understand? So what's the next one going to be? 180 is between what and what? $169, $196, $13, $14. That's a 27-point spread, yeah? I need to go 11 away from that. So it's 13 and 11/27, right? Right? Which is pretty darn close to 13.3, because 11/27 is pretty close to 1/3. Everybody okay with that? Everybody good? Everybody understand what I'm doing? Okay, so 300, it's between 17, 289, and 18, 324. Right? 11 out of 35-ish, right? Right? Which is pretty close. So 17 and 11 out of 35, which is pretty close, squiggly equal sign, to 17 and 12/36, which is 17 and 1/3 again. Everybody okay? All right. So with cube root, you already know how to do it now, right? It's just an estimate. So 45 is between what and what? 27 and 64, right? Closer to 27 or closer to 64? It's almost right in the middle, isn't it? So what's the cube root of 45? 4.5? 4 would be 64. I got to be lower than 64. So what would it be? It's closer to 27, so 3, maybe 3.45. Everybody cool? Slightly less than half, because 27 is slightly less than halfway. Is everybody good with that? What about 405? What's it between? Go up to my cubes. 405 is right in there, isn't it? Closer to 343 or closer to 500? Closer to 343, right? Little less than half again. So what? Maybe 7.4. Everybody okay? You don't get that, Sammy? Okay. Well, that's the estimate part. 405 is between 343 and 512, yeah? Right? Well, it's closer to 343, isn't it? Halfway between 343 and 512. Do some rounding, 340 and 510. 17, right? So it's 170 here, yeah? So halfway would be 85. With me? So 340 plus 80 is 420, right? So 420 is about halfway. So this would be about 7.5. With me? But I'm at 405, so I'm going slightly less than 7.5. Cool? That's why I showed you up here with the decimals and the fractions. But in cubes, the spreads are so much bigger that because all we're doing is estimating, right? And finally, 176 is between what and what? Oops. On our cube list, 5 and 6, right? Am I closer to 5 or am I closer to 6? Closer to 6. So I'd say it was 5.6. Everybody cool? You all right with that, Sammy? Yeah. Everybody else okay with it? Okay. Remember, estimating is a tool for you guys to make sure your actual math, when you do it, is going to work. All right? What's your next page? Excellent. That's what I want to be your next page. And it should be, if I am not mistaken, there's my purple book. I don't know if I have it printed. Yes. Okay, that is all calculator work. Okay? Now, I want to remind you of a couple of things. You all know how to find square roots on your calculator, yeah? But I want to remind you a couple of things. One, does that exist? No. It's an imaginary number, right? Two, does that exist? What's that?
That's just like the negative of the result of the square root.
The negative of this. So that is -4. Everybody cool? Yeah? Okay. What is this? You have to think back to your exponent laws. That's the square root of 16 over the square root of 9, which is 4 over 3. Everybody cool there? All right. So everyone's good with square roots, right? I mean, you did them to death in grade 9, yeah? Cube roots are a little more tricky. So the first thing I want to do is make sure everybody knows how to do a cube root on your calculator. First of all, look on your calculator and see if you have a cube root button. Most of you do. Yeah, it's usually a shift of the square root button. So see if you can find that. And then you use that button just like you use your square root button. Okay? So you would go, depending on forward or backwards calculator, if I wanted the cubed root of 27, forward calculator, you're going to go cube root button, 27, and you might have to hit equals. Backward calculator, you're going to do 27, cube root button, and you might have to hit equals. And the answer is, of course, what? 3. Can everybody make the calculator do that? Now, if you are so unlucky as to not have a cube root button, you're looking for this button, which I'll draw in green, X root. And if you've only got that button, then you've got to input your index. So it would be 3, X root button, 27 equals. And then on a backwards calculator, honestly, guys, I can't remember how to do it. So who has a backwards calculator? Do you have a cube root button? Score. Score. Cube root button's the only one we need for this, I think. I don't think I asked for any fourth roots. Okay? So go.